We're going to talk about programming with types in C#. The reason I'm doing this is, when you're at university, you encounter a lot of really interesting ideas, and using types to enhance our programs really stuck with me. And so, like different things resonate with different people. This really resonated with me. And so I wanted to share this super fun thing with you guys. So if my clicker will work. Cool, there you go. Our agenda is we're going to agree on what the idea of a type even is. I'm going to lie to you that code can actually be self-documenting. I'm actually quoted in Simple Talk as saying, if you claim your code is self-documenting, I claim get off my team. We're going to talk about something called phantom types, and then we're going to go do some more work limiting what we can actually do with a type. And the reason we're going to all this trouble is we want to eliminate, everyone wants to eliminate errors from programs, right? Nobody likes it when their programs crash. And some of you will be like, but I have unit tests. And unfortunately, a unit test can only prove the presence of errors. It can't prove the absence of errors in a program. And so in this case, we're going to use a type system to eliminate some errors. We can't necessarily get rid of all of them because no one wants to write that program, but we can at least get closer. So what even are types, right? Types describe the allowed values in our program. And int is a very, very small number to an incredibly large number. An unsigned int is like the same thing, but shifted up a bit. A string is 0 or more Unicode characters and also null, right? Types just describe what's allowed to exist in a particular part of a program at a particular time. As an example of this, I have a particularly bad server class. What this says is that a server is identified by 2 strings, which can literally be anything, as long as they're valid strings. So if we look at this class, right, and I have these 3 particular servers, unfortunately, C# will believe that all 3 of these servers are perfectly valid servers. Unfortunately, the poop emoji is not a valid host name. How do we know this? Well, RFC 1123 actually tells us that host names must be ASCII, and specifically, they must be the low 7 bits of ASCII, which is valid because the top bit is now used to indicate how long your Unicode grapheme is. Right? So all 3 of those technically were perfectly valid servers based on what we wrote. That's not actually true. So the first step we can do is we can annotate this with disallow null, or you could use C#8's nullable reference types, but I wanted to make this more explicit than just using compiler pragmas. Hooray. But what this tells us is that a server is identified by 2 strings, which can be anything as long as they're not null. Cool. Now I know that I can't have that server S1, right? Nulls are not allowed. Unfortunately, this does still mean I can have poop emoji and Charles Dickens as a server name and IP address, neither of which are valid server names or IP addresses. So what we can do now is keep digging around and discover, hey, there's a system.net. I can bring in an IP address. And so I can no longer use Charles Dickens as an IP address. And clearly I have won the day. Hooray. Astute readers will have noticed that I can still put in a valid IP address and the poop emoji. Boo. Also, that guy could technically be a host name. So what we could do even better is keep rooting around inside of system.net and discover that, hey, NetBIOS name is also a thing. And since we here at Redgate only are aware of Windows computers, at least on SQL Monitor we are, NetBIOS name is a perfectly fine thing to use as a server name. Now, obviously, we could be more generic than NetBIOS name and write something that actually says, hey, as long as these are all in the lower 7 bits of ASCII, like this is a completely valid server name. But I was feeling lazy and didn't want to write that particular piece of code. Ultimately, what this gets us, though, is by adding that NetBIOS name and IP address, I now know that my only valid servers are actually valid servers that I can reach, right? Localhost 127, blah, blah, blah. No poop emoji, no Charles Dickens, no nulls. And so now what I've done is I've limited this server type to only allowing the values that I actually want. I might accidentally use the phrase inhabitants of a type later on. I'm sorry if I do. Actually, I'm not sorry. I love that phrase. But think of a type as a house or building, right? And we want that house or building to only describe the things that belong in it. And so when we're picking the correct data types, we're ensuring that we only represent valid data in our programs. What we're doing now as well is we're documenting our interfaces as much as possible with code. This is really what people should be meaning when they talk about self-documenting code. It's not that you gave your variables or parameters clever and clear names. It's that your types actively and accurately describe how they can interact with the rest of the program. Which brings us to talking about self-documenting code. What does this function tell you? Nothing. It can do anything, right? Jeff and I were joking. Technically, it's the identity function for objects. Really, we can make a more generic identity function, public default, right? All this can do, according to type theorists and Haskellers, is return the same value you pass into it, because you don't know what that T is. Anyway, so getting back to our server, right? Types provide documentation. One of these tells us a lot about what makes for a valid server, right? Two strings don't really tell us anything apart from you've found up to 2 gigabytes of characters and you're chucking them into something called the server. That's not helpful. But I can constrain this and say, well, it has to be a valid NetBIOS name and it has to be a valid IP address. And that now tells us a lot more about what a server actually is. Data types can also be really surprising, right? I pulled this from some example code that Core gave us. Not picking on them. This is perfectly valid for using on the internet when you don't have quite so rich types going across HTTP. But let's say we want to find out how many licenses are available for a server. A nullable int is surprising because what does null license mean? I don't know. What does a negative number mean when it comes back? I don't know. What does 0 mean? I don't know, right? And so all of these are really weird and surprising things. And you'll find this a lot when people have to work with very primitive types and they don't really know what they're doing. There's an entertaining story about people looking at a database and finding a whole bunch of dates in this particular database that were July 4th, 1776. These people were not Americans. They did not understand the significance of this date, but some American software vendor had used this to indicate that no date had been provided instead of, using null. Anyway, by documenting our return types, right, we can sort of construct explicitly like the values that are actually allowed. So rather than having a nullable int, we can do this, we can describe what entitlements actually are. So we can start by creating an abstract class called entitlement count. We don't actually want to instantiate some raw value of this. We want to force other programmers to deal with this value when they encounter it. And so now we can say, well, we know that sometimes customers won't have given us money. For whatever reason, they're unlicensed. But we also might have customers who have given us all of their money. And so they get an unlimited license. And we also are going to have customers who are licensing in different ways. So they're going to have some kind of count. I've made this an unsigned int because negative numbers are weird, right? You can't like take away like things that you don't have. And also this entitlement unit just tells us whether or not it's sort of like per seat or per CPU. And so now we've gotten to a point where we have a countable number of entitlements, or we could represent unlimited entitlements, or we could represent the fact that you don't have a license to use our software. And now we can even write something that says, okay, I have a server, I'm going to get the entitlement count for it. And this server is a non-null NetBIOS name and a valid non-null IP address. And I'm going to get back some kind of entitlement count. And I have to understand what that means. And so this is mostly documenting itself, right? If I have that nullable int, I have to go and find the documentation for that particular method and hope that the person who wrote the method decided that they actually should also write comments that describe what the code is doing. And in this case, my types are doing most of that hard work for me. All right, so we can use types to better describe what a function is doing. And if those types are descriptive enough, they can replace a lot of our documentation. Lots of fun, right? Hooray. So moving forward, I'm also going to use this thing, talk about this thing called phantom types, which I think is really cool. And I couldn't find a good definition of this in the C# world. So I pulled this from Rust by example. A phantom type parameter is one that doesn't show up at runtime, but is checked statically and only at compile time. So as we talk about this through C#, I'm going to be using generics. Just note that the generic is actually still present in C#. You don't need to well actually me. I do know that the generics are still there. But that documentation goes on to say that sort of by using these extra generic type parameters to act as markers, right, I can sort of keep refining how my program behaves and force my program to behave well at compile time. By doing this work ahead of time, I'm going to eliminate a certain variety of runtime errors, because who likes crashing software? Nobody. Peter's raising his hand. I know you like Haskell, Peter. So our licensing problem, right? It's possible to do some silly things where I could create something that has a server level entitlement, and then I could call get user entitlements with the server entitlement, because this may not be specific enough, right? This limited entitlement, I had to check it at runtime the way it's written right now. Boo, right? It's a server, not a user. What's going on here? And hopefully someone would catch this in code review. Hopefully you were all awake when you were reviewing that pull request and not just putting the ship it squirrel in the review and then clicking approve and labeling it merged green. Hopefully. That's a lot of hope to put into a code review. Anyway, and someone is going to say, but code review should catch this. Theoretically, yes. Hopefully you were awake. Code can throw runtime exceptions. Yes, but runtime exceptions are awful, especially if I can stop them from occurring at compile time. Right? So let's make it so this code couldn't even compile. And what we're going to do is we're going to use a phantom type. We had that enumeration before, right? That's just sort of discriminating the type of entitlement. That's all it does. It just says it's a user or a server entitlement. But we can just push this out into a type. And so I create a new public abstract class called entitlement unit, and I just put in user and server, and I seal these so you can't do anything weird with them later, because these shouldn't hold values. They just tell us what's going on. And so now I can actually go ahead and say, well, this limited entitlement is actually generic over that entitlement unit. And so now all I have to have is a number in here. It's a number of the number of licenses you have, but ultimately it's got a whole bunch of information attached to it telling you how exactly you can use this number. So now I can actually type my function, making it impossible to send a server into the get user entitlement count. Hooray! So now our first one compiles, right? I can send user entitlement into user entitlement count, but I can't send a server entitlement in. Pretty cool, right? I've just stopped this error from occurring at runtime. There is a slight problem because calling something get user entitlement and count implies there are other functions with equally silly names like get server entitlement count. And I can just push this into the type system and do overloading. Ooh, shiny. It's pretty cool though, right? I can just sort of solve this problem, or I could even case over this with a single function if I wanted to and do the right thing in there. I'm having fun. Leave me alone. So what about other subtypes, right? I don't have to implement sort of a get entitlement count for those, because if it's unlimited, just keep saying, yes, license all the servers. And if it's unlicensed, just keep saying, no, go away, give us money, right? I can't represent infinity as a number. I also can't represent a lack of entitlements as a number. You might say, well, it's 0. Well, that's not actually true, because I can add 1 to 0 and now I have a license again. And you know, hey, by saying there are no licenses available, that's different than they're saying 0 licenses available. Yes, this is very pedantic, but so are computers. Also, you know, if I'm going through here and I'm writing a switch case statement, default theoretically throw an exception. And I don't necessarily want to go through and have functions using switch case and default. I know I just said that in the last one that we could case over the type, but maybe you don't want to, because a lot of times people will say, oh, here are my two valid cases. And if I get past this, I should throw an exception. And if you really like not throwing exceptions, there's actually a Roslyn analyzer called Switch Analyzer that fails your build if somebody throws an exception in the default case of a switch. We should all install that and fail those compiles. Right. But ultimately, what we've done here is a good thing because we've made that class of licenses that are countable, and the things that can't be counted, infinity, well, okay, infinities are countable, but the things that we don't actually want to count, an infinite number of licenses or an absolute lack of licenses, those don't have a number that can be counted, right? The moral of the story here is stop throwing exceptions, start failing compilations. As a different example, we can also talk through an idea of validating data with phantom types, right? I have data that comes in 3 states. It's unvalidated, it's validated, or it's wrong. And so we're going to pretend this is a form. And so now I have 3 states of data where my data is either unvalidated, it's validated, or it is invalid, right? And so now here's a class, hooray! And I have this make form data that takes a string and it's going to return form data that has not been validated yet. Cool. And now I can say, okay, we're going to validate it and whether either return an invalid form or a valid form. Hooray, right? This ensures that I'm only going to attempt to validate data that I have not tried to validate before. If it's wrong, I don't want to try to validate it again. It's wrong. Simple as that. And if it's valid, I don't need to validate it again. So this method makes sure that our data is in the exact shape that we want, both on the way in and on the way out. So we can go and we can write code, blah, 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 hooray. The user put in the wrong email address. It's bad, whatever. It has emoji or something, I don't know. But now, after I've called validate on it, I have to check that data and decide how to behave with it, right? I can't just push form data in. I'm not checking a .isValid bit, right? The type itself tells me whether or not the data is valid. And so this is enforcing it through the compiler, right? So hooray, cool. And now I can even add a class to submit form data that only allows valid form data to actually be submitted. I can't submit invalid form data. Developers have to validate the form and then deal with that either before they can actually proceed. And so, right, that form data object itself can use an internal representation of the data that nobody ever needs to know about when they're working with it, right? You just put things in and stuff comes out. You don't have to worry about what's going on in there. You just know that that type changes over time. Data is going to move through the program from state to state. Remember state machines in your introduction to the theory of computation course, right? Probably not. It's just circles with arrows. Cool. Right. But the cool thing here is only data in the appropriate state can move through the program. This is really valuable because it makes it easier to think about how our programs are structured and what errors can occur at any different place in the program itself. And it's really easy to add more states, right? I can just keep adding stuff in here and keep building my state machine. And so now that I have an in progress and completed, like maybe it's not a form really, it's a wizard. So now I can say, okay, well, you can save this halfway through and you have an in progress form. And then I can complete the form and it takes an in progress form and it turns it into a completed form. And all kinds of other stuff has been left out because reasons. And so now I'm forcing it that the only way to validate a form is that the form has been completed, right? I can't attempt to validate an incomplete form because the incomplete form is inherently invalid. So now I'm just putting more and more rules from the program into the type system so I don't actually have to think about them in the code, right? It's in the types. I don't have to worry about ifs. Ugh. The end result, again, I'm encoding state and types. I'm pushing my runtime errors into compile time errors. And if my program doesn't compile at all, that means users can't get that error when they try to run it because the program didn't compile in the first place. And so now my compiler is actually enforcing control flow in the program itself via these types. And the last thing we're going to talk about is putting limits on functionality. And we've actually already done this, right? Our entitlements example limits a lot of functionality. This is, of course, what types do. They describe allowed behaviors. Other cool stuff you can do is you can get super nerdy and limit equality, right? By default, we can't compare two entitlements unless they're the same type with the same generic type, which does mean that this code can't make it out into the wild, right? Even though they're both the number 67, 67 users is very different than 67 servers. Hooray. But you can also keep doing other more interesting things with this, right? Usernames are strings, but I probably shouldn't be running starts with on usernames in my programs. That's not really a valid way to compare users. Jeremiah.peschka@redgate.com is very different than jeremiah.peschka@gmail.com. That second Yahoo probably shouldn't have any access to Redgate stuff. And there's a lot of other things you just shouldn't be doing on certain types of data, right? So I can limit comparisons on usernames, right? Yes, technically it's a string, but I'm going to make a better thing to encapsulate that string. I'm going to make a username, and it doesn't implement any sort of equality comparisons, right? Because I don't actually know, like, as somebody consuming a username, I don't know what makes them equal. And instead, right, I might want other identifying bits in there that I need to compare. I don't know how it works. I don't care. And I probably don't even want to call like double equals on it. Instead, what I really want is some sort of ID, right? And the implementation of this doesn't actually matter, but the point is I can't compare two strings to one another, right? I can't accidentally coerce a string, some sort of Charles Dickens novel, into being a username, right? The only things that should be compared are exact inhabitants of a type, only two usernames. So the cool part is now I can chuck anything inside this ID that I want. And I can also say, well, it also has to implement some magic thing that I have, like identifiable, because that's really easy to say. Right. And so the point is I can keep specializing these types that I create to make my programs work in exactly the way I want and to prevent errors in exactly the ways that I want. So I can eliminate possible runtime errors. I can make it so that usernames or server names can only be compared exactly. You can't do a starts with, right? So I'm also sort of removing explicit dependencies on things like get hash code, which are just filthy implementation details that nobody should actually know anything about. Maybe users are the same person if every third bit is the same in the string. I don't know. Who cares? It's a computer. And really sort of what we've learned, right, is that, again, types define the set of allowed operations on the data they contain. And we can create custom types to keep refining our code to restrict what's allowed, to clarify behavior, and to document what's not obvious. So with that ID type, I don't know if I should be comparing usernames directly, but I can just chuck that username in an ID, and then hey, it's going to do whatever it needs to do. And I can even provide a default implementation that just always returns false. That way I know two things are never equal. Cool. So to wrap up, right, types make our programs cleaner to read. Strings don't tell me anything. Ints tell me a little bit, but not really anything. But the more I can refine that, the more rich I can make those types in the program, the more they tell me about the program, the more I understand about it just by scanning the code. And I can also use types to move runtime errors into compilation failures, which is really exciting because that means users don't see runtime errors anymore. It just didn't build until I fixed it. I can also represent meaning without needing anywhere near as much documentation, and I can eliminate unrepresentable states in my program, which is also really cool because programs shouldn't just get into these goofy states, right? That's actually like a crash at this point, not just somebody threw an exception with a weird string in it. So yeah, that is sort of my take on programming with types. There's no need to like go to crazy languages with dependent types where your types have programs attached to them themselves and your head might hurt while you're trying to read them because suddenly your programming language is actually a formal proof of existence. Ugh. Yeah. Thank you for coming to my TED Talk. I'm gonna stop sharing and look at some questions.
If everyone give Jeremiah a round of applause, that was great. Oh, although I must admit, we'll have to say boa conversa, apparently.
What now?
Well, you speak Portuguese, right?
I do not speak Portuguese. I am a monolingual, filthy American.
So you speak English and American English, right?
I don't really even speak English, because I can walk in like 40 seconds in any different direction and find a different word for bread.
And let's not get started on the whole Adidas thing, right?
Yeah.
Do we have any questions? I haven't seen anything pop up in the chat so far.
David L was excited about seeing angle brackets.
Yeah. And Peter loves runtime errors.
Peter does love the runtime errors.
I've got a question.
Yeah.
Where's the... So I'm a big fan of strong typing, as anyone's ever spoken to me before. However, it comes at a cost in a language like C#. So David's mentioned angle brackets. Like you do increase the visual noise, the syntactic gobbledygook to get these kind of types into a language like C#.
Yes.
Is there a trade-off there from the kind of visual disgust that the strongly typed like thing there? Where do you draw the line?
I mean, code is all kind of inherently ugly when it's not Haskell. So, you know, we've already paid the price of having an unattractive programming language. Why not make it uglier like Jackson Pollock? No, I do think it does add some sort of something you have to parse with your brain, right? And nice tooling, nice IDEs with color coding and that kind of thing. They do make it significantly easier to look at this, and they call out these sort of weird bits that you're putting in. But yeah, that does, it is noise. I guess for me, I prefer to have everything specified as well as I can. And so from where I come from, I like it in there because yes, I have to read it and I have to parse it and I have to understand it. The other interesting part is that now in C#, you know, with var keywords, you don't have to see the type to the left of your variable name. And then with the new magical constructor syntax we're getting in C#, whatever the next one is, you can just say new curly boy, a whole bunch of parameters and close the curly boy. And you don't actually have to see types apart from in your function names or your method names and the classes themselves. So I think that as languages are changing, it eliminates the noise that a lot of types put into the programs. Unless you're writing Rust, in which case you have to see it all the time, whether you want to or not.
Jeremiah,
yeah.
I'm super conscious now of how I ask questions after the 7 sins. But as you were going through that, I was just looking at it and thinking that these things were now, you were turning like strings into types. At what point do you then think that they, like in part of OOP, what point do you then start adding behavior to those? Do you think it like drives you towards that, or can you wrongly go down that path?
I mean, I sort of view it as, you know, yes, you are sometimes adding behavior to these types themselves. And there is probably a point when it does get a little bit overly meta. And I think the answer I have is really wishy-washy, which is like, you really have to be careful about your use case and what you're actually trying to build. You know, if I'm making a web server, it probably just needs to accept strings and puke strings. And then the more complex my application is, I think the better it is to specify a lot of that behavior in there. Yeah, it's like a non-answer. I'm sorry.
Yeah, no, that's fine. It was a bit of a weird question.
No, it's an interesting question to actually think through, though, right? Like, how much of this is too much? I did a course at university on dependent types, which is my types have proofs that they exist, and you know, your types are basically programs in and of themselves. And it does get very painful when you're like, well, now I have to prove that a number +1 is larger than the first number, and you're like, God, I hate my life. Right. And so it's like, how precise do you need your tools to be? And there's also that sort of basics of like, once you've proven these base things, and by proven, I mean the program compiled, right? You continue to refine it, and you largely only have to make that proof once. And once it compiles once, as long as your rules don't change, it's in there forever, and you're good at that level. There are bad JavaScript jokes going on in the chat.
There are. I was going to say the stringly typed code equals weakly typed code. But, you know, let's not get into the double, triple equals mess, right?
Yeah, that actually comes from the fact that Brendan Eich wrote JavaScript as a love letter to Scheme, where Scheme has Scheme has two forms of equality as well, but they're much more obvious in Scheme because you don't use operators like this in Lisp-like languages.
Sounds like another lightning talk you could do.
I've got a question. Have you, in the example you gave about the entitlements, I was wondering if you put any thought into how you could apply the same sort of approach to a web API, something that doesn't provide that kind of, doesn't provide types essentially.
Yeah, yes. So a lot of what you would do in this case, like a lot of what I would do is sort of the whole programming in layers approach, or I think it's the postal principle, right? Where you take this awful string that you've got, and it's much more like the form data, right? Take this string and then I turn it into something that I don't know a lot about, and you slowly refine that until you either get to something that is good and can continue through the program, or it's bad and you inform the user. So yeah, it's the less you know in advance that's coming in, the more you just have to keep sort of poking it one step at a time and be like, are you actually a string? Do you contain content? Like, is it content that I want? And yes, it feels very tedious, but sort of once you've written that program that solves that problem once, you know, it's sort of solved, but getting there is very tedious.
Oh, thanks.
So there can be a bit of kind of maintenance overhead for this thing if you're changing your domain model.
Yes.
Like if you have a stringly typed language, it kind of doesn't matter because it's all strings or it's all ints or whatever. Whereas if you've actually encoded your domain model into the type system, change your domain model, you have to change your type system, and now all your functions have to change and all your. Is there a way to mitigate that? Just to.
It does add a lot of work. The flip side is you are making sure that your program always encodes that domain, and you can also choose the strength of that domain as you're building it, right? So it is up to you to decide how strong your program is going to be in its assurances about what data comes through. And you even see a lot of this when you look at actual, like when you look at really robust JavaScript libraries, they take something and they're like, are you a string? Are you my string? And they sort of very slowly and painfully walk across the data that comes in. And there's sort of like 95 lines ensuring that this thing that came in is appropriate. And then they're like, and now put a semicolon at the end. Which is unfortunately like the reality of programming, is that the looser the inputs I have, the more effort I have to put into making it correct. But you know, with the domain, like once that information is in the domain and you sort of understand it, domains typically don't change a lot. So yeah.
Don't know if we've got any more questions there. I know we have gone over a little bit, but given it's lunchtime, I'm sure people aren't too bothered. No, well, thank you very much for attending, everyone. If I want to give another round of applause for Jeremiah for his wonderful talk.
Yay. Thank you all for showing up.
Yeah, look forward to seeing you on the couch / table / whatever tomorrow. Thanks, everyone.
Thanks.